Hi, everybody. Welcome back. This is IM2 6.1.2 Special Right Triangles and Trigonometry. And our learning goals. Our learning goal is that, well, we've got more than one, but I will be able to calculate trigonometric ratios for special right triangles. One, I will be able to calculate trigonometric ratios for special right triangles. And two, that you will be able to calculate the value of sine squared theta plus cosine squared theta for different right triangles. You know, like a better, okay, triangles. Period. Okay, 6-26. Examine the diagram at the right. We will prove an important trigonometric theorem. Okay. Keep in mind, these questions add up to a proof of an important theorem. Let's write equations for sine of theta and cosine theta. Remember? SOHCAHTOA. Sine is opposite over hypotenuse. So that's y over 1. Sine of theta equals y over 1. Cosine of theta is adjacent over hypotenuse. So that's x over 1. Okay, using our results, we're going to write the value of sine squared theta plus cosine squared theta. All right. Using our results from part A and our knowledge of right triangles. Okay, well, I'm just going to do y over 1 squared plus x over 1 squared. I'm going to start with that. So sine of theta squared plus cosine of theta squared using substitution equals y squared plus x squared. It's over 1, but 1 squared is just 1. Okay, and it's a right triangle. So since it's a right triangle, I can also say, and by Pythagorean theorem, y squared plus x squared equals my hypotenuse squared, which is 1. 1 squared. So this means that sine of theta squared plus cosine of theta squared equals just 1. Okay. Does this relationship appear to be true for all angles? Use 6-25 answer. Now, we did 6-25 last class. 6-25 was to fill out the table of trig values. So we have it, it's right here. So 6-25, we're going to use these values to calculate the sums below. Let's look. This is just convincing ourselves that we've just proved a really big time theorem. Okay. Sine of 30 squared. So that's 1 over 2 squared plus cosine of 30 squared plus root 3 over 2 squared. Let's see. So this is 1 squared over 2 squared plus root 3 squared over 2 squared, which is 1 plus 3, because root 3 squared is just 3 over 4, which is 4 over 4, which is 1. Whoa! Okay. So this statement, sine of theta squared plus cosine of theta squared is 1, is true when theta is 30 degrees. What about when it's 45 degrees? Okay, let's check. So this is sine of 45 degrees, that's root 2 over 2 squared plus root 2 over 2 squared. Okay. That equals root 2 squared plus root 2 squared over 4. No, sorry, over 2 squared, which is 4, but for a different reason than I thought. Okay. That's 2 plus 2 over 4. Hey, that's also 1. Whoa! It's not always going to be 4 over 4, though. That's a coincidence. Whoa, 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 whoa. Okay. Okay, 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 okay. Let's look at 627. Let's see where this paper is taking us. What the journey is. All right, testing examples that we did in part C, that's this one up here. It can give us an idea of whether a statement is usually true, but to test whether it is always true, which is a powerful thing to be, you need to prove a general case. Sometimes it helps to start with a theorem that you've already proved. Okay. Let's write an equation about the side lengths of triangle A, B, and C at right and explain how we know it's true. You know, okay. Well, I know A squared plus B squared equals C squared because that's the Pythagorean theorem. Where are we going with this? Where are we going with this? Let's keep looking. Okay. First of all, I'm pretty sure I'm going to need this triangle on the next page, so I'm going to put it on a sticky note so we can take it with us. So let's try it. Let's make apart our triangle here. This is A, B, C for sides, capital letters for angles, A, B, C, and here's theta. Let's go. So I know A squared plus B squared is C squared because that's Pythagorean theorem. Now I see how it ties in. Okay, we have to prove that sine squared theta plus cosine squared theta plus equals 1. I know I'm saying it differently than that's how it's written. That's because I know how it's usually said, but I'll try to speak how it's written. Sine of theta squared plus cosine of theta squared equals 1. So first we're going to write sine theta and cosine theta for this general case triangle. So sine of theta is going to be opposite over hypotenuse equals A over C. Cosine of theta equals B over C. I'm going to write sine of theta squared plus cosine of theta squared. So I have A over C squared plus B over C squared. And let's do it again. Okay. I'm going to rewrite this without parentheses. So this is A squared over C squared plus B squared over C squared. What is my equation equal to? All right, I know where they're going with this. Do you remember part A when we said, hey, I know that A squared plus B squared equals C squared from part A? Look back here. That's where they're going with this. So we've got a squared plus b squared is c squared. What they want you to recognize is that if I were to divide everything on both sides, then I would get a squared over c squared plus b squared over c squared equals c squared over c squared, which is 1. But look, that's also the same as sine of theta squared plus cosine of theta squared. Sine of theta squared plus cosine of theta squared. Sine of theta squared plus cosine of theta squared. So we have sine of theta squared plus cosine of theta squared equals 1. Now, just as an aside, everybody, you'll usually see this written as such: sine squared theta plus cosine squared theta equals 1. And I don't know why, because what this means is that. Sorry, it's probably annoying. All right, anyway. What did we learn? We learned that if you're given an angle, sine of that angle squared plus cosine of that angle squared is 1. Let's do a bunch of examples. I'm just gonna put them right here. So for example, if I told you that sine squared 20 plus cosine squared x equals 1, x has to be 20. If I told you that sine squared 55 plus cosine squared 65 equals 1, I would be a liar. No, that's only true for the angle 55. These angles have to match. Anyway, I hope you have a beautiful day. This was lesson 6.1.3, and I'll see you next time. Bye, everybody. Thanks.